So maybe it's time to start. But I need a selfie for my wife because she doesn't believe I do these things. Okay, 1, 2. Okay, perfect, thank you. Sorry? Okay, so I usually start my presentations with trying to impact your mind and with big numbers. So I will start with $2 trillion, and this is not my salary. It's the cost of poor quality code, but just only in the United States for 1 year. But if you say, okay, but I'm not very enthusiastic on considering this amount of money or why my company is paying that money. 4 days is the time that usually a developer spends on fixing bugs and, in an application per month. So this is a big number that probably we can consider now as developers. We'll try to talk about clean code or code quality, also in the AI era. But if you allow me, I will try to do it following a story. Story that involves a monster, a hero, and some fights. Let's try to make it fun for you. I'm Jonathan. I'm Java champion since 2020. I'm also one of the leaders of the Barcelona Java community and also the co-founder of JVCN Conf and DevVCN. Is a conference that we host in Barcelona every year for the last 2 editions with more than 1,000 attendees. So if you don't have anything else to do in June, maybe Barcelona is a good destination. But I've been developer for more than 30 years using lots of languages. But one of the languages that I liked the most was Delphi. Has anybody here used Delphi before? Okay, perfect. Maybe you are as old as me. But I'm working as a developer advocate for Sonar. Here is a QR if you want to know more about me, or just simply ping me. I'm a human, and we can have a conversation. I work for Sonar. Sonar is the company that is behind SonarLint, SonarCube, and Sonar Cloud. Does anybody here that doesn't know anything about one of those tools? Everybody has heard about SonarCube? No? Nobody? Perfect. I will explain it. SonarLint is a free plugin that you can install in your IDE that will detect issues, bugs, vulnerabilities, security directly as you code. It's free for commercial purposes. SonarCube is also free on the community edition. It's a tool that will analyze projects, again, doing the same, checking your, your code and detecting issues, best practices, or even vulnerabilities. And Sonar Cloud, that it is the hosted version, that is also free for open source projects. So you have it in our machines. It covers more than 30 languages, as I said, directly in the same project, even covering Kubernetes deployment files, Docker, or even Terraform. Well, if you want to know more about me, just ping me. I brought some swag from Sonar, so glass cleaners, pens, stickers. If you want, just take them after the talk. This is the QR for the slides if you want to follow them as I'm going through them. But the agenda is basically, I will try to define what it is poor quality code. So maybe we have an idea of what is clean code, but let's see what is the lack of clean code. The cost of it, I've shown you 2 numbers. Let's see more numbers about it. And then finally, I will define what is clean code. And spoiler alert, it's not only a book. It's more than that. Then I will show you, I think it's a very interesting point. I didn't know about this, but when I arrived at Sonar more than 1 year ago, well, I saw our telemetry. So our tools are capturing telemetry from all the projects that are using our tools. And it's quite impressive, the kind of errors that people are constantly having in their projects. Maybe you won't believe some of them, but it's true. Then I will show some interesting hints that you can follow if you want to do clean code with your code. And also, what about AI? Is it AI something that it is 100% reliable? It's something that it's correct all the time and that it gives the right answers? Spoiler alert, no. Then I will show you some tools that you can use in order to follow clean code and avoid issues. And does anybody here follow the TV series called The Mandalorian? No? No Mandalorian? No Sonar Cube? Come on. So The Mandalorian is like a spin-off from Star Wars. And they have one saying that they say is like, this is the way. So I will show you which is the way to follow clean code. Finally, some references if you want to know more about this topic. Let's go deep into the talk. But let me first introduce you Porky, that it is the monster of poor quality code. It's a hydra of 3 heads, clearly a monster, right? And which are the attributes of this poor quality code or Porky? So basically, it's code that it is buggy, has lots of errors that we need to fix. Those 4 days that we invest every month on fixing those errors, this is one of the characteristics. Has a lot of high coupling, so every time that you need to modify something, you will end up modifying a lot of classes across the code. Low cohesion, because domains are not together, so you have the same concepts of the same domain scattered across the packages or the modules. It also uses obsolete libraries. That means libraries that are coming with CVEs, or low performance, or even bugs. But I know it's hard to keep up with the versions of the libraries. It has a costly refactoring, so you are going to invest a lot of time refactoring that code because the low cohesion, the high coupling, and the obsolete libraries. But it's more about Porky. It's not only about layout, about cleanness. It's also about security. Because you are not following clean code, you are suffering from CVEs introduced by those libraries or even introduced by you. Because you don't have the time to check all the code. And sometimes bad code skips into the repository. Also, it can have memory leaks because you are creating resources. And in some cases, because the code is so connected, there are places where you are not releasing those resources. So in those cases, maybe you are suffering from memory problems. And also low throughput, because your classes are doing too much. When you call a method, maybe you are doing a lot of things that you are not needed, because you have this spaghetti code and big methods and big classes. This can lead to non-deterministic results, again, because you have a lot of things to do. You have a lot of resources to release. And depending on the flow that your code is following, you are not going to have the expected result because it is doing too much and in a complex way. Also, it's going to be hard to create all the tests that are covering the use cases that the application is going to have in runtime. It's complex. So maybe you are not covering all the use cases. So let's move to which is the cost of the monster attacks. So basically, I introduced the presentation with this more than $2.4 trillion on poor quality code. But just only putting focus on finding and fixing bugs is more than 600 billion. Always remember this is for 1 year and 1 country, United States. So if you want to check the report, here there is the link. And well, this graph really explains the situation. So the less defects that your code is having, the less time you are going to invest on fixing those bugs. So the cleaner the code is, the less defects it's gonna have. But in this story, we have a hero. I call her Clean, but basically, the hero for this story is you. So every developer is in this story. And what a regular developer does daily? Well, basically, introduces new features. Well, that's why we are paid. We fixed some bugs, maybe not that happy. I wasn't that happy, but who knows? Maybe one of you is. But let's say that this should be the ideal situation. But also, we have little time for fixing tech debt. Who thinks that have more than enough time to fix tech debt or fix bugs? Who thinks has not enough time to fix tech debt or fix bugs? And who thinks I don't have no time at all to fix tech debt or fix bugs? Okay, so more or less, we think we don't have enough time, but we have some time. Usually what happened to me is that sprints were being full with a lot of tickets to solve bugs and tech debt, but then those tickets were just pushed forward, so moved to another sprint, and yeah, it was always like crazy to fix the tech debt. But also, this is a very important point. We study new technologies, and we try to be up to date, and that's why you are here. This is an amazing step, and for 1 second, I would love to for you to feel proud to be here, because how many developers do you know? How many developers are in the Brussels area? But only here, it's a small portion of them. So this makes you very important. Continue with that. I'm very passionate about communities, so continue with that and try to bring new people to the community, because this is, I would say, at least for me, the best thing that it has happened professionally for me. So thank you very much for being here and continuing the community. But also, what we do is to rant about all code. We hate that code that it's, oh man, I need to do this again. Just up to the moment that when you do git blame, you discover that it was you who introduced that code time ago. So this is what I think we usually do in our daily basis. But hey, we now have a helper. We have a sidekick, someone that is going to make our life beautiful, sunny, the AI. So in this story, we have this sidekick. I call it aid. So the AI code generator. Now we need to either work less or either work on more funny things. And we have lots of flavors of this. So we have Gemini, Replit, Copilot, Codium, Tab9, well, you name it, lots of them. And the important thing is that the adoption on AI-generated code is growing and growing and growing. And it's calculated that it will be the 70% of the code will be generated by AI in 2027, compared to the 10% that it was like last year. And 3 important points here. The AI-generated code is only accepted around the 40% of the times. So there is a 60% of the time where we reject the code that the AI generator has generated. It also increases 55% our speed. That's great. Another important point here is that the usage of AI generators is 20% more in junior developers. I think this is something very important to consider, either because AI-generated code is used in more or less complex tasks, or either because juniors are more used to use AI-generated code. But definitely we need to put focus on this because it could be a problem if those juniors don't have the exposure to real code and they are more focused on using tools to generate that code. But the thing is that code generated by AI, we cannot use it as it is. This is a, well, for me it's nice meme. This is the Batman from the 60s, 50s. So it's like you don't have to commit blindly the code generated by AI. You need to check it. So every time that you use code generated by AI, the first thing that you are doing is to introduce a new reviewer yourself. So you are doing an extra step of reviewing other people's code, that it is the one that is coming from the AI. Even from their warning, even Copilot says, make sure to verify any generated code by us. So this is something that we need to have in mind, very deeply written. Because AI-generated code is not correct in the most of the times, just only in 29% of the time. And content generated by ChatGPT is correct in 68% of the time, but maybe because ChatGPT is used for different purposes than Copilot. But we have here an idea that correctness is not a thing when using AI to generate code. Even when we use these generators, the number of issues introduced by them, depending on the complexity of the task, are huge. So from easy, it's around half, but to hard or complex tasks, it's around 70% of the time that they introduce issues. And the issues are like different. Well, I'm not going to read everything, but it's like using multiple variables, at the same time reassigning parameters, yes, why not? For loops instead of for each or streams. Well, there are several issues that are going to be introduced by AI that we need to check. And we are going to even have compilation errors if we use this code generated directly from Copilot. No references. So it's important to have in mind that they are not correct a lot of times. I did an experiment, so I used Copilot to ask, generate a method that iterates a collection, doing the sum of its integer value and calculating the average. Well, the result was a for loop with an intermediate variable assignment. While you can use Java 21, the collector's thing, sorry, it's Java 12, I think, collector's thing method from the language in order to produce a more reliable code than a standard one. So it's not using a very old method, it's using a for loop. So even it's not creating clean code, maybe it's correct, but it's not doing the good approach. You can see this circle and simple 12%. This is calculating the cyclomatic complexity of the code. So in the case of the one that I created myself manually, it's 0% complexity, but the other one has a 12% complexity. This is also a concept I will explain later. But which are the goals for the developer and the software in terms of clean code? Well, basically, our hero discovers that there is like a clean code warriors order that claims to fight against the bad code, and that it has like 4 main principles that are that the code needs to be consistent across all your base. So it's not using different approaches to solve the same situations, or different namings, or different ways of organizing your code. So it needs to be consistent. Adaptable, because it needs to be designed using modularity in order to evolve easily whenever it is needed without impacting a lot of things. Intentional, because it needs to be very clear what it is doing. So in terms of naming, in terms of the way you define the code in your methods, needs to be very clear what it is doing. So some of the times it's better to just break it down in several parts, but make very clear what is the intention. And responsible, because it's better if you don't break any copyright law, and if you don't use any offensive language inside your code base. But these are the goals for the software. But in clean code, there's also a very important part, that it is the person, you, developers. And the point is that whenever you submit code, it's important that you feel confident about the code that you have submitted. It's not that you are going nervous every time that you create a pull request. You need to be confident that it is good enough and it's clean enough, and you are not going to receive lots of comments in the pull request. Also, you need to feel proud because you are sure that you are submitting the right approach, the best solution, not a complex one, not a solution that is going to be, commented or discussed in the pull request. And finally, you need to be skilled. So you need to learn about all those issues, about all those, the new code that you introduce and the new way you define your code need to make you a better developer every day. So these are like more internal goals, but I think it's important to not separate the person in the clean code process. It's about the person and the software. But as I told you at the beginning, we have telemetry. So our hero, before going to try and kill Porky, she thinks, okay, but let's see, is that bad? It's, I don't know, the software is that bad in the market that it's really important, this thing? Well, with the telemetry, we have like 1,800 million of issues detected. And I took only the top 10. And it's more than 500 million issues. And for that, the most detected issue is that we deliver too complex code. I will explain the concept of cognitive complexity because maybe you are more familiar with cyclomatic complexity. But for those of you that do not know what is cognitive complexity, I will explain it. There is a lot of unused code. Local variables, function parameters, private fields, private methods, not used. Imports, and there is a lot of commented out code that you never know if the right situation is to remove that code or uncommented. You never know. It's tricky. A lot of track uses of to-do tags. There is an example of one Apache Software Foundation famous project that has a to-do in their code base that is 10 years old. So I assume that one day they will decide to do it. But meanwhile, the to-do is there, 10 years. So the situation is, okay, just remove the to-do or just do it. In Java, there are a lot of issues detecting the usage of raw types. So in Java, we should put type in the collections. If not, we can suffer from runtime errors. So it's important to put the type. String literals duplicated, meaning that every time that you refactor your application, you are going to have to change a lot of places the same string. So it's better just to have constants for that. And generic exceptions thrown. when we should throw specific or concrete exceptions. That's important for the consumer to know what to do. And the classical reference to null that will cause null pointer exception. So I group them into complexity, depth, or useless code, comments, design, and error and null handling. But in the security context, we have a lot of issues regarding the usage of non-secure passwords. So they are not using the right algorithms to create passwords, and they should change. This is execution into XML parsers. So we should check also the XML files or content that we are consuming. Cross-site scripting, also important to check in our code. And credentials hard-coded. So there are lots and lots of projects with credentials hard-coded. And believe it or not, there are lots of applications that are just simply scanning GitHub in order to find users and passwords to do non-expected things. So it's super important also to check all of those things. And then the last one is that we can suffer from path injection if we are taking a path coming from a user value, and then we try to walk the file system using that value. So basically, credentials and injection or scripting. This is like an overview of all the issues that we are detecting with our tools. Remember, with its 1,800 million issues out there. But our hero decides to learn new tricks and in order to fight better Porky. And let me show you some. Let's start with vulnerability and security challenges. Has anybody tried this hack with the car in order to avoid having a fee for high speed? I don't know. I find this meme everywhere, but I don't know if this is like a myth or if it has happened in reality. So basically, with credentials should be not hard-coded, well-used third-party services in order to handle the credentials for you, not put them in plain text in your files. In order to not suffer from SQL injection, instead of using string concatenation, just use parameter injection with Java, and then you won't suffer from SQL injection. HTTP request redirections. In this case, we are using a value coming from the user, and we are using it directly. We should have a list and check that the destinations are included in a expected list, so not just do it directly. With this issue, we can argue a lot, but this is my point of view. There are two ways of doing things regarding databases. So you can use DTOs or you can use directly entities up to the REST endpoint. My point is that you should always use DTOs in order to communicate with the user or the consumer, and then use entities in order to store information in the database. The entity needs to reflect what it is in the database, and the DTO needs to reflect what it is in the API. It doesn't have to be one-to-one, or it should not be. There are tools to create this mapping, like MapStruct, but it's better, in my point of view, to use DTOs, just because in some cases you can receive an entity that you didn't expect that the entity had some fields populated. So if you are not sanitizing the entity, you are going to store information that you were not expecting. Regarding bugs and code smells, so for those of you that are using Spring Boot, first thing, learn Micronaut or Quarkus. This is the best thing that you can do. And the second thing is define the packages where Spring is going to start scanning the bins. if you don't specify those packages, either putting the Spring application annotation into a class that it is in the default package, or because you are having an empty string in component scan, Spring will scan the class path. It will scan itself. And then maybe someone can put a jar in your class path, and then it can create unexpected results. Another interesting trick is that if you are using multi-threading, and for whatever reason you need to stop the thread for some time, or stop doing what you were doing for some time, instead of using the sleep method, it's just use the wait method, because the sleep is blocking the thread for that time, and the wait is releasing the lock and making the thread available for other processes. So it's better to use wait. This is very obvious, but it can be skipped into any code base. So you do the method in the left. Who thinks it's going to fail? And who thinks it's going to be green? Who doesn't think anything? OK. It's not going to fail. It just simply will go green. Fine, but you are not asserting anything. You don't have any condition. So you can miss the condition, but the test will be green. So it's also important if you can have someone that checks that you didn't miss any assertion. But the same with having not even asserts. If you have a method like the one in the left, it's going to be green, fine, no problem, but you are not testing anything. So that's also important, that you have something that warns you if you don't have a test in your test method. With resources, well, with Java, we have auto-closable resources. Therefore, it's better to use them, and Java will release them by itself. You don't have to do a manual release of the resources. So also, again, if we have something that is checking our code and warning us, hey, you should use auto-closable try with resources, it's also a nice thing. Regarding design and complexity, as I told you before, there is a concept called cognitive complexity. With this cyclomatic complexity, both two methods are having the same cyclomatic complexity, 5. But I think you agree with me that the right one is way easier to understand from a first sight. So cyclomatic complexity is not helping us here in order to decide which code we are going to refactor. So then we have cognitive complexity. It has a different calculation, considering indentation and breaks. So now we have a cognitive complexity of 9 in the left part and a 1 in the right part. It's the same code as we had before. But now it's better for us to understand that, hey, maybe if we need to choose which one we need to refactor, it's clear the one that we need to put focus on. So this is also a very important concept if you use cognitive complexity. But you need something to calculate it. There is also an issue, class, depending on lots of classes, that, well, yeah, this method is very clear, but reality is not always that clear. So it's also important to know that one class that we are trying to submit is having lots of dependencies, and maybe we should refactor that. And the same for the length of our methods. We can suffer from brain method issue, that it is a method that is doing a lot of things. It's going to be even hard to test it. So we need to break it down. But we need something that checks the code and sees that we are putting too many things into one method. With public methods containing selectors, this is a bad idea. When you have a method that a Boolean argument is going, or a value in the parameters is going to decide which is the flow. You need to do the flow, so that selection, the path selection before that, and then you can test every method isolated without having this branching. But if we go to Java version specific, so every Java has like special things that you need to consider. So if you're using Java 12, instead of using the regular switch, use the switch expression. Way easier, we get rid of breaks, and we don't have to use intermediate variable assignment. So you just simply return a value. With Java 16, I think that we all agree that we need to go towards immutability. But sometimes the APIs are not helping us. In this case, before when we were using a stream with a collection, if we wanted to collect the result of those mappings or whatever, we were using a collector and a toList. This was returning a modifiable list. If we wanted to have an unmodifiable list, we needed to explicitly say it using the collectors to unmodifiable list. But now with Java 16, we don't have to specify anything. The stream has already a method that it is toList that is going to return an unmodifiable list. So it's a consistent way of doing things across our code base. Also, if you want to follow immutability, the best thing is to use records. With Java 16, we also have records that are immutable, and they already provide methods to string, that equals, and are the perfect solution for immutability and the same way across all our code. With Java 19, if we want to ask for a number of elements into a collection, and we want to do it at the initialization status, if we said, OK, let's create a hash map of 1 million elements, Java was not creating 1 million elements. So every time that we were asking for or putting values, Java was deciding, OK, now I need to create more elements into the collection. With Java 19, if we use the static method, new hash map, now it is creating all those elements at that moment. So in summary, the idea of all of these slides were not that you learn all those tricks, but that you get a bit dizzy, that you get, wow, that's a lot to do. Yes, it's right. So there are lots of things to do, a lot of things to consider, and every time that you commit code and every time that you review code. So our hero asks, OK, yes, it's a hard task to do in myself. Are there any weapons? And definitely there are. So there are static analyzers, so linters, basically, that you can use in your IDE, or even external tools that are going to statically analyze your code. You can use PMD, Sonar lint, obviously, checkstyle, Sonar cube, and you can have others. Even IntelliJ has its own linter that it is checking for issues. Or even GitHub has their own security checker on their side. So there are lots of tools that we can use. I can talk about SonarLint in this case, but you can get the idea and you can apply to other tools. So basically, it's important that you see the issue highlighted in your code. Also, you have a list of issues. But the important part here is that you have a long description of which is the issue and how to solve the issue. It's not only that you see that there are issues that you need to fix, it's that there are issues that you can learn from. This is a very important point. Do not consider these tools as a black box auditing and complaining about your code, but consider them as sidekicks that are helping you to be a better developer if you learn from them. Apart from the static analyzers in your IDE that will be sure that you are not committing any bad code, so you are sure that you are fixing a lot of issues just before anyone is reviewing them, the company needs another tool that will ensure that only clean code is committed to the main branch. And for that, there are quality gates like SonarQube, but there are other tools too, that they are going to check the whole project, and then they will, according to the quality gate configuration of your company, allowing a certain amount of minor issues or a certain amount of cognitive complexity, they will allow your code to be merged or they will be rejected. So basically, 3 focuses of these tools is main. The first one is clean as you code, so not considering a second step or trying to fix your code, but fixing the code as you are typing it. This is very important. And also learning from it, because you have a nice description of each issue and you are going to learn from it. And even you can use that for your team retrospectives in order to put in common some issues that you have found. I'm going down to the end of the presentation. The important thing here, the way of doing clean code is, okay, which is the path that our hero needs to follow? Just try, I don't know what was your experience, but in my case, every time that I implemented SonarQube in any company in the past, we were in a moment that we were happy about our project, and after installing and running SonarQube, it was like, this is crap. We had thousands of issues or hundreds. But this is overwhelming. This is not going to happen. You are not going to fix them all. So you don't need to focus on old code, just only on the new code. New code as compared to the previous version, on the last X days, or a reference branch. Because code, as everything live on Earth, dies too. So it's calculated that around 20% of the code changes every year. So as you can see in this chart, the code in red introduced in 2010 is almost not existing in 2018. But the same happens with all the years. So basically, there is absolutely no point on trying to fix old code, because after some time, it will disappear. So just focusing on the new code that you are introducing is going to make that your project is healthy in few years. If you want to know a bit more about this concept, it's called the Git of Theseus. It's based on a story called the Ship of Theseus that says that once, years ago, a lot of years ago, they had a ship. And every year they were just replacing one piece for a new one. And after several years, they were discussing if the ship was exactly the same ship as they had before. In this case, the ship is our project, and yes, the project is the same, but it has changed. So there's no point at all on focusing on the old code, just only on new code. So basically, there are 2 ways of fixing the problem. Trying to remove all the issues and kill Porky directly, or chopping one head at a time and focusing only on the new heads that are appearing. Yes, as you said, the right approach is to clean as you walk, cutting one head every time and not trying to fix all the code. Let's finish the presentation just with my conclusions that the clean code not only has impact in the software, but also on the company, reputation, and in the team, in morale. It's harder to keep a motivated team if you have bad code. That usually developers do not have enough time to fix that overwhelming number of issues or tech debt. So following the clean code approach will have an important impact on the software, but also on developers. You are going to learn, you are going to be happier, and you are going to be more confident. But there are lots of things to consider. Just only considering the number of rules that we have in SonarLint, for instance, we have more than 650, I think, for Java, around 600 for JavaScript, 400 for Python. It's hard to cope with that big number. So definitely you need a tool. You need tools. There are lots of them out there. Lots of them are open source. Our tools are open source, but there are others. You can try others. But definitely you need to use tools to help you in order to follow the clean code approach. And finally, that only a portion of your code is going to survive. So there's no point on trying to fix all code. Just only focus on new code. Here are some references if you want to know more about this topic, especially reports that I found about numbers and cost. And that's all. Thank you very much for following me, for being here. And here are the QR for the slides and for the feedback. Please, 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 Porky, please, give me feedback, rate the talk. Even if it's a bad rating, this will help me. So definitely give me feedback and follow the slides. And contact me if you need more, I don't know, discussions or we want to know more about this. Thank you very much.